Shall we start the class? Can you hear me? Okay. Thanks, Utkarsh. I'll share the screen with you. We'll start the class. So, in the last class, we were discussing regarding the. I'll just once again review what we discussed in the last class. So we discussed the sliding mesh gearbox, the overall layout of the sliding mesh gearbox. Then I have told you regarding how to draw the line diagrams. So we have drawn the line diagrams. Then we have seen what are the disadvantage, what is the disadvantage of the sliding mesh gearbox. After doing that, then I said that to rectify that particular disadvantage, we shifted to constant mesh gearbox, where all the gears are in continuously mesh with each other, and dog clutches are used to engage and disengage to change the gears. So that we have seen. So after that, I have shown you, I have discussed the certain aspects which will be related for solving the problem, that is the gear ratio, then the total speed reduction, then overdrive. What do you mean by overdrive? And then I said that the generally the reverse gear ratio is either same or higher than the first gear ratio. So this was the discussion. Now I will shift to the presentation. We'll have the we'll discuss this thing in the presentation. So as discussed in constant mesh, why I am showing you the presentation, because in presentation the actual photographs are there for the constant mesh gearbox, so that your idea of the engagement and disengagement of the gear will become very, very clear. So as you know that all the gears are always in mesh in the constant mesh gearbox. So gears on the counter shaft are fixed to it. Gears on the main shaft are free to rotate. Dog clutches can slide on the main shaft. This we have seen. Slide on the main shaft and rotate with it. Dog clutches engage with gears on the main shaft to obtain the desired speed. Advantages over sliding mesh gearboxes: helical or herringbone gears can be used in these gearboxes, and therefore the constant mesh gearbox, they are quieter. That means you don't have the noise of the gear engagement and power transmission. Since the gears are engaged by dog clutches, if any damage occurs while engaging gears, the dog clutch unit gets damaged rather than getting the damage to the gears. Now this is the layout of the constant mesh gearbox which we have drawn. In this case, gears on the main shaft and lay shafts are constantly engaged, and rotary motion is transmitted to main shaft by engaging the dog clutches. So this we have seen. Now इसके साथ आगे बढ़ते हैं. See, this is the actual constant mesh gearbox. Okay, so this is showing you the configuration of the constant mesh gearbox. The neutral, reverse gear, then reverse gear. Then this is basically the synchro mesh between the third and the fourth gear. This is the another synchro mesh device which is in the first gear and the first gear and the second gear. So this is the synchro mesh device. Now we are going to see how these meshings are actually taking place in this particular gearboxes. So the neutral, this is the configuration when the gearbox is in neutral. That means we are not in a position to understand the exact thing. Yeah, all synchronizer sleeves are located in the center. Center input shaft turns and output shaft is stationary. That means this is the input shaft which will turn and the output shaft is stationary. Okay, so that is neutral. Now the from input, so this is the configuration of the power is coming from this side as they have shown in this photograph, whereas in the other one it was reverse. So power is coming from this gear, it is going here, and the first gear is in engagement. So you get the output. The first gear, small gear driving big gear, and high torque is there. So this is the actual engagement. Now the engagement will become, see, synchronizer engages to the first output. Okay, the synchronizer engage to the first output gear. Small gear on the counter shaft drives a large gear on the output shaft, giving high torque and low speed. So that is the thing. This is the second gear now. The 1/2 gear synchronizer is moved away from the first gear and engaged to the second gear. So this is the synchronizer which is moved from this. So these are, you can say, they are, it is not showing the engagement, whereas it has shifted over here. And this is the second gear engagement. The power is getting transmitted in the second gear. Then coming to the third gear, this is the third gear engagement. Now the synchronizer, this synchronizer will come into the picture. Okay, and this is the last gear. That means from input to output, the fourth gear is driving gear ratio is 1. So that is the fourth, you can say, gear. So no torque multiplication here. Synchronizer is moved to engage the fourth gear. The synchronizer sleeves locks the input shaft directly to the output shaft, no torque multiplication. So, and this is the fifth gear, that means the overdrive. Okay, so this was the fifth gear, which is nothing but the overdrive. Overdrive means, as I told you, the engine shaft turns at a lesser speed compared to the output shaft. So this is the reverse gear. Synchronizer is moved into reverse gear on the output shaft. Power flows through the counter shaft. Reverse idler gear changes the direction. Reverse gear and to the output gear. Reverse light switch is engaged at the same time. So light switch, that means it gives the indication for some of the vehicles that the reverse gear is engaged. In now modern gear, they are fitted with the camera. So whenever you engage the reverse gear, on the screen you can able to see what is at the back side of the vehicle, because the back camera gets activated. Okay, now synchro mesh gearbox. The sliding synchronizing units are provided to equalize the speed of the gear and the dog clutch. This we have seen yesterday. Now working of the synchro mesh device, this we have also seen, so will not get into it. So this is the thing which is given in the theory, whatever we have seen in the yesterday's video, and this is how the synchro meshing is shown in the 2D diagram. So synchro mesh device in disengaged position, and this is the engaged position. This is something like your dog clutch. When we will study the dog clutch, you will find that there is a cup and cone kind of arrangement which is used for the wedge shape arrangement, which is used for the engagement and disengagement. Okay, so these are the various types of synchro mesh devices which are available, which are used in practice. there is not the single design, but there are many designs of the synchro mesh. Okay, now with this we'll try to solve the problems on the design of the gearboxes. So this was the theory. I will share the PowerPoint presentation with you. I hope yesterday I have shared all the lecture notes in the form of PowerPoint, in the form of slides, PowerPoint PDF file. Okay, so just go through that and please make sure that you read those slides along with the book, because if at all there is some error, you may able to rectify it, because those slides are prepared by me in a hurry, so there are chances that there may be some mistake in that. So please rectify whatever mistake I found. I have corrected it, but I leave it to you now. So now we will start with the designing of the gearbox. So please have calculator, pen and pencil with you, along with the I don't know how many of you use the pen and pencil, but I am going to ask you the values for the for certain calculations. Okay, so first problem, the simple one. Okay, in a gearbox, the clutch shaft pinion, the clutch shaft pinion has 14 teeth, and low gear main shaft and low gear main shaft pinion has 32 teeth. Okay, the corresponding lay shaft pinion corresponding lay shaft pinions have 36 teeth and 18 teeth. Okay. The rear axle ratio is 3.7:1, and effective radius of rear tire is 36.5 centimeters. Calculate the car speed in above arrangement at an engine speed of 2500 RPM. So sir, please read the problem once again. In a gearbox, the clutch shaft pinion has 14 teeth and low gear main shaft pinion has 32 teeth. The corresponding lay shaft pinion have 36 teeth and 18 teeth. The rear axle ratio is 3.7 and the effective radius of the tire is 36.5. Calculate car speed in the above arrangement at an engine speed of 2500 rpm. Sir, how do you draw this? सर इसको कैसे निकालेंगे सर? Sir, please tell me what is the gear ratio? Can you tell me which gears will be with the mesh? What is the gear teeth of the gear mounted on the clutch shaft? सर मैं निकालता हूं, आप मुझे बताइए कि सर ये क्लच शाफ्ट है, यहाँ गियर है सर, इसको कितने टीथ होंगे? ये ले शाफ्ट है सर. प्लीज आंसर दिस आफ्टर रीडिंग दिस. फोर्टीन. चलो ये एक आंसर हो गया, ये 14. और इसके साथ जो मेश हुआ है उसको कितने टीथ रहेंगे? थर्टी टू कैसे रहेंगे सर? चलो एक दूसरा एक यहां पे रहेगा. सर अभी आपको समझना चाहिए. This will have 36 teeth. This will have 18 teeth. This will be 32 teeth. Because please note that to keep the center distance constant, you have to have the sum of the teeth have to be equal. That means the 14 plus 36 comes out to be 50. 18 plus 32 comes out to be 50. So these have to be there. Now gear ratio. Gear ratio will be multiplication of the first gear train multiplied by the second gear train. So for first gear train, it will be number of teeth on the driven shaft, sorry, driven gear by driving gear, or is coming here, then it is going here, then it is from here, it is going to be here. Sure. तो सर ये 36 by 14 मल्टीप्लाइड बाय, इसके लिए क्या होगा? 18 32 by 18. So please tell me what is the gear ratio? सर इसका वैल्यू कितना आता है बताइएगा. 4.57. चलो 4.57. Okay. Now the overall gear ratio. This will be your this gear ratio into axle ratio. So gear ratio multiplied by axle ratio. So this 4.51 into what is axle ratio given? It is 3.7. So please tell me sir इसका वैल्यू कितना आता है? 16.91. चलो 16.91. Now this 16.91 that is equal to the speed of engine shaft divided by speed of wheel shaft. So I will say engine shaft is NE, wheel is NW. So from here NW is equals to NE divided by 16.91. So it is 2500 divided by 16.91. Sir, how much is this value? this comes out to be 147.8. ओके, सो नाउ अभी इसके हिसाब से सर स्पीड निकालो, स्पीड ऑफ द व्हीकल. Speed of vehicle is equals to 2 pi n into r omega divided by 60. This becomes omega into r. तो ये दिया है आपको 2 इंटू 3.14 इंटू n दिया है. ये उसने आरपीएम दिया है ना, तो ये आरपीएम ही आएगा. सो 147.8 डिवाइडेड बाय 60. अभी रेडियस आपको कितना दिया है? 0.365. तो सर यहां से निकालिए, ये वैल्यू कितनी आती है सर? सर इसका वैल्यू बताइए कितना आता है? तो 5.65 मीटर्स पर सेकंड. सो सर ये किलोमीटर में कितना आएगा सर? 5.65 इंटू 10⁻⁻³ ये हो गया आपका किलोमीटर, डिवाइडेड बाय 3600 मल्टीप्लाइड बाय 3600, ये आ गया आपका आवर. तो सर कितना आता है सर? ये तो सेकंड्स हो गया, तो यानी ये हो गया 5.65 इंटू 10⁻³ इंटू 3600 किलोमीटर पर आवर. 20.34 आता है. चलो 20.34 किलोमीटर पर आवर. Sir, now in this, if I say that the overall transmission efficiency of the vehicle, that means the RPM getting transmitted from engine to wheel is, let us say, 95%. So what will be this speed? Will the vehicle able to move with this 20.32 or 20.34 kilometers per hour if I say that the transmission efficiency is, let us say, 95%? So if eta transmission is equals to 95%, then vehicle speed will be how much? सर कितना होगा? मल्टीप्लाइड बाय एफिशिएंसी या डिवाइडेड बाय एफिशिएंसी? 95% का मतलब ये है कि जितना, अगर 100 इंजन का आरपीएम रहेगा तो आपको व्हील के पास सिर्फ 95 आरपीएम मिल रहा है. तो इट इज 20.34 मल्टीप्लाइड बाय 0.95. सो इसका वैल्यू कितना आता है सर? 19.32 ले लेता मैं, 19.32 किलोमीटर per second. Sir, where from this transmission efficiency comes, why it comes, that we can see in the practical class today. ठीक है, तो आज का जो प्रैक्टिकल क्लास रहेगा तो उसमें सब ये चीजें हम लोग डिस्कस करेंगे. ठीक है, तो everybody understood this particular problem because the today's practical is based on this. So now shall we solve the problem on design of the gearbox now? Today's practical will be based on this. तो अभी सर हम लोग एक डिजाइन वाला प्रॉब्लम करते हैं, काफी लंबा प्रॉब्लम है. तो चलो सर अभी हम लोग डिजाइन का प्रॉब्लम सो सर लिखिए प्रॉब्लम. अ गियर रेशो फॉर स्मॉल पैसेंजर कार ये ए नीचे है. गियर रेशोज फॉर स्मॉल पैसेंजर कार आर एज follows. So first gear is 4.2:1. Second gear is 2.56:1. Third gear is 1.52:1, and top gear is, which is nothing but the fourth gear, is 1:1. Okay. Inverse diametral pitch of each gear. Inverse diametral pitch of gear, that means I'll write down each gear, may be assumed as 3.25 millimeter. Okay. The smallest pinion in the gear train must have at least 15 teeth. सर ये प्रॉब्लम पड़ी है, ये बहुत सारा डेटा दिया हुआ है इसमें. ओके. The engine speed, the engine shaft speed is 1.52 times lay shaft speed. Lay shaft speed, full stop. Assuming straight teeth, and one single lay shaft in gearbox and one single lay shaft in gearbox, calculate. पहले तो उसने पहला ये दिया, center distance between the main shaft and lay shaft. Center distance between the main shaft and lay shaft. Second बोलता है number of teeth in each gear wheel. Number of teeth in each gear wheel. Third बोलता है actual gear ratios on the basis of result to above. Actual gear ratio on the basis of results to above. तो सर ये प्रॉब्लम आपको समझ में आया क्या? जरा पढ़िएगा, ये आपको क्या क्या डेटा दिया हुआ है, तो सर आप पढ़िएगा. गियर रेशियोज ऑफ स्मॉल पैसेंजर कार आर एज फॉलोज, यानी उसने 4 गियर रेशियो दिए हैं. Inverse diametral pitch of gear means each gear may be assumed to be 3.25. अभी ये inverse diametral pitch क्या है तो ये आपको ढूंढना पड़ेगा सर. ओके, सो inverse diametral pitch ये आपको देखना पड़ेगा is 3.25 millimeter. The smallest pinion in the gear train must have at least 15 teeth. The engine shaft speed is 1.52 times the lay shaft speed. Assuming straight teeth and one single lay shaft in gearbox, calculate center distance between the main shaft and lay shaft, number of teeth in each gear wheel, actual gear ratio on the basis of results to obtain above. यानी इसमें जो आपको रिजल्ट मिला है उसके बेसिस पे उसने एक्चुअल गियर रेशियोज का कैलकुलेशन करने के लिए बोला है. सर इसका थोड़ा सा फिलॉसफी समझ लो. प्लीज ट्राई टू अंडरस्टैंड द फिलॉसफी ऑफ दिस पर्टिकुलर problems which are asked on the design of the gearbox. Please understand that there is no formula as such that you have to use that formula and get the value. That is the first thing. Keep this thing in mind. Whatever design we do, that is basically the iterative process. That means you start with certain thumb rule which are acceptable universally, and then based on that go on refining the design. So it is not the problem. These are not the problems which are having the wrong answer or right answer. Okay, these are the problems wherein you have to follow the logic and go on deriving the dimensions or whatever data is asked or whatever data is required. In industry also, you have to start. Suppose you are working in the gearbox manufacturing or design company, and if you have been asked to design the gearbox wherein you can be given the maximum speed with a tire ratio and other things, then how do you design the gearbox? How do you do the gearing steps, and how do you calculate the torque requirement? So generally the gear ratios, they are most of the time are in the range of, let us say first gear ratio is 4.2, or hardly it ranges from 5 to 4. Okay, so usually this is the thing. Do you know the process of designing of the engine? See, engine is never designed from the blank white paper. You have to have the research engine which is available. Then based on the criteria, you decide that what should be the RPM, what should be the capacity, what should be the torque. Then you go on changing the parameter in the research engine and you try to get the parameters which you have targeted. And once you get that, then with certain variations from the goal, then you can go on refining the design of the engine. That means you have to do all the experiment first on the research engine. Every company, every engine manufacturing companies has got the research engine, and that is basically the starting point for designing of the engine. So if you are let us say all of a sudden you say that I want an engine of having capacity this and this size and it should be very small and all those things. So that will not come as it is, because first you have to do the iterations on the research engine and then go on modifying it and try to get the answer. See why I told you, because in fluid mechanics you said that, see, I have assessed your paper based on the final answer, but that is not the case here. This is totally opposite. That means there you have to have only one answer right. Here the thing is not different. The thing is different. Here you may have two different approaches to get two different answers and both may be correct. So please keep this thing in mind. Is this clear whatever I told you? सर ये समझ में आया क्या कि इसमें एक कोई फिक्स आंसर नहीं है सर. आपके अगर ये फिक्स आंसर रहता तो सब व्हीकल सेम रहते. If there would have been a fixed formula and fixed answer, then you would have seen that all the cars which are running on the road, which has got the 5-seater capacity, that means driver, co-driver and 3 passengers at the back, they may be having the same design, but that doesn't happen. I'm telling you, because every car has the different philosophy of the designing. For example, please try to understand that the designers from the Japan, they will design a very compact car. Designer from the America, they will design a very lavish car only for the 5 people sitting, because the design philosophy is altogether different. The people from Japan, they are very much, you can say, careful about the space which is available, or very sensitive as far as the utilization of the space is concerned, because right from their childhood they are being taught to use this space in a very optimistic way, because the space availability is very less in Japan. Yeah, and if you compare to the US, then right from the childhood they have seen everything grand, because there is no issue of the land as such. It is almost 7 times of India, having one third of population of the India. Now you can imagine, so the amount of space which is available there. So usually you will find that the American buildings, the American designs, they are basically lavish compared to the Japanese. I am not, see, both the designs, they are correct. Okay, but it is basically the mindset of the people who are staying in those particular country. In India, we are very much, you can say, sensitive about the cost. So we will always think of the, I'm talking about the general people. This is, there may be exceptions in that. But in India, we are very much, you can say, concerned about the economy. That means the expenses which we are going to incur on a particular kind of task. So we feel that first of all we buy the vehicle, then we see that uska fuel economy kitna hai. But that is not the case with the people from the USA. For European people, it is in between the Japanese and the American people. So you will find that always. So have you heard that any of the small car designed by the American designers? Sir, have you heard of that? Even if you see the American movies, the cars which are shown in the American movies, they are lavish. Even if they call it as a truck. Whereas in India, if you say the truck, the image is something different. Am I correct or not, sir? Okay. So this is basically the philosophy, and both are correct. The Japanese people are correct because there the cost and there the space is the issue. American people are also correct because there is no issue of the space. So you will find the lavish car. So chalo sir, so India is in between. European people, they are in between because we have all the constraint nowadays regarding the parking and the cost. ओके तो सर ये प्रॉब्लम को कैसे सॉल्व करना है? तो सबसे पहले सर द फर्स्ट थिंग वी हैव टू डू इज फर्स्ट वी नीड टू ड्रॉ द कॉन्फ़िगरेशन. सो शैल आई शिफ्ट टू द न्यू स्क्रीन? Yes or no? Okay. So I'll shift to the new screen. तो सर सबसे पहले क्या करना है? तो लाइन डायग्राम ड्रॉ करना है. सो सॉल्यूशन में configuration of gearbox. से पहले तो सर हम लाइन डायग्राम ड्रॉ करते हैं. तो ये सर अपना हो गया प्लस शाफ्ट और ले शाफ्ट का डिजाइन. ये हो गया आपका आउटपुट शाफ्ट. So I'll say that there is output shaft. ठीक है. सो सर ये गियर वाले अपन डायग्राम ड्रॉ करते हैं. This is not to the scale, so please excuse me for that. So you may say that कि सर ये तो to the scale नहीं है. So agreed. So I will say that this is gear A, this is gear B, this is यहाँ पे एक गियर छूट गया है. चलो ये this is gear C, this is gear D. So here I will write down the first gear engagement is power will be transmitted from A to B, B to C, C to D. Okay, so this is the first gear. Now second gear is A, B, C, D हो गया. ये E और A, ये F हो गया. So second gear is A, B, E, F. That is going to be your second gear. Now third gear because here the fourth gear and one reverse, so that is why the gears have increased A, B, C, D, E, F. Then this is G and this is H. So third gear is A, B, G, H. Now the fourth one is basically, the fourth one is you are going to have the power transmission from here. That is why I am showing this with the dotted. So AHFD, AHFD. So these are the four gears he has given, and one reverse gear he has not mentioned, but still we have to write it down, that A, B, C, D, E, F, G, H, I and J. So this is the reverse gear configuration is A, B, I, J and D. So is this clear, sir? सर ये आपको समझ में आया? ये 4 gears है ना, so that is why this is the this is to be rotated with the engine speed. This is the rotation with, you can say, lay shaft speed, and that is the output speed. Okay. Now the first thing, गियर रेशो इन दी फर्स्ट गियर. सर अभी बताइए कि गियर रेशो ये जो है ये आपका ले शाफ्ट. सर थोड़ा सा इटरेशन रहेगा, लंबा रहेगा ये थोड़ा. सो गियर रेशोस, तो हम लोग सर ये फर्स्ट गियर का गियर रेशो लिखेंगे सर. तो फर्स्ट गियर का गियर रेशो क्या है? G1 is equal to TB divided by TA multiplied by TD by TC. This is to be given, this is 4.2, this is given. सर ये आपको दिया हुआ है. Okay, what is gear ratio? Driven by driving. Okay, so this is given. Now speed of engine shaft NE by NL, this has to be equals to TB by TA. That is, he is saying that it is 1.52. This is also given. Yes or no sir? ये आपको दिया हुआ है. Now what I can say, अभी यहां से ये दो इक्वेशन का यूज करके we can write down 4.2 is equals to 1.52 multiplied by TD by TC. Do you agree with this? So from here TD by TC, सर इसका वैल्यू बताइए कितना आता है. तो सर प्लीज लेट मी नो व्हाट इज द वैल्यू ऑफ दिस TD by TC. 2.76, correct. So 2.76. Okay, now we have to use a certain relationship. So in order to keep the center distance constant, we have TA plus TB, that has to be equal to TC plus TD, that has to be equal to TE plus TF, that has to be equal to TG plus TH. Do you agree with this sir? सर इससे सहमत हो जो मैंने इक्वेशन लिखा है? बिकॉज इन ऑर्डर टू हैव द सेंटर डिस्टेंस. यस, चलो फिर I will say from this equation, can I write down TD plus TC divided by TC is equals to 2.76 plus 1 divided by 1. This has to be equal to, from this relationship ATB and A, this has to be equals to TA plus TB divided by TC. Is this okay, sir? ठीक है. Also, now from this equation, TB plus TA divided by TA, that is equals to 1.52 plus 1 divided by 1. This comes out to be 2.52. So sir, आपके पास ये एक इक्वेशन है, आपके पास ये एक इक्वेशन है. So from these two equations I can write down from the next one equation, TB plus TA is equals to 2.52 times TA. अभी ये इक्वेशन से हम ये लिख सकते हैं. Now TB plus TA, this comes out to be 3.76 TC is equal to 2.52 TA. Do you agree with this? सर TA एंड TC का रिलेशनशिप ऐसे निकाल पाएंगे सर? Now if you see the text, then it is saying that, sir ये समझ में आया क्या आपको? This equation, have you understood? Okay. So now from the text of the problem it says that, ये सर ये यहाँ पे देखिए, अरे यार, हाँ सर ये यहाँ पे देखिए, the minimum teeth, the smallest pinion in the gear train must have at least 15 teeth. तो सर हमने ये सब सर्कस करके देख लिया, ठीक है. हमको ये लगता है कि ये TA को ज्यादा टीथ रहेंगे कंपेयर टू TC फ्रॉम दिस पर्टिकुलर इक्वेशन. TA will have more number of teeth compared to TC. Yes or no, sir? So I will say that adopt TC is equal to 15. This is purely assumption. You may assume TC may be 16, 17, 18, 19, 20. There is no issue as such. He is saying that it should not go below 15. So I say let us assume that TC is 15. So if you use this relationship, then it is 3.76 into 15 divided by 2.52, that is equal to TA. So TA comes out to be 22.38. So I see that this TA cannot be the integer. So I am saying that, sorry, this cannot be a real number, it has to be integer. So I will say that I assume that TA is equals to 22. You may assume 23 here as well, but since here in this problem we are saying that if it is not more than 22.5, so let us assume that it is 22, because gear teeth, they cannot be in fraction. Correct? Sir, यहाँ तक क्या are you agree with this? See what I am saying, that instead of this 15 you can assume 18 as well, 17 as well, that is your choice. Okay. So I assume that it is 15. Even if you write down here 16 also, you are not wrong. Please try to understand. Again, I am telling you, this is the iterative process. It has to satisfy this constraint. TA plus TB is equals to TC plus TD, TE plus TF. Once you fix, then you cannot change. That is the idea. That is the logic. Okay. So now if I say that TA is 22, automatically you can get TB. TB, TA, sorry, ये है ना, ये relation है, TB by TA is 1.52. So TB is 1.52 times TA. So now it is 1.52 into 22. So this comes out to be 33 0.44. So again I assume that this approximately I see that this is 33. तो सर हमने ये जो TC है इसको हमने 15 लिया है, उसके हिसाब से ये आ गया आपका 22 और TB आ गया आपका 33. नाउ जस्ट सी this 22 plus 33, this becomes 55. So this is 15. So this gear is going to engage with gear D. So gear D must be having 40 teeth. To make sum of the teeth equal, we are assuming same module of gears of all gears, right? Yes, sir. What is module basically? सर मॉड्यूल का अभी तो सर यहाँ पे फिलहाल तो कोई लेना देना है नहीं, अपन वो बाद में करेंगे सर उसका. अभी आप मॉड्यूल को मत लाइए पिक्चर में. आई विल टेल यू हाउ टू डू इट. मॉड्यूल इज डायमीटर डिवाइडेड बाय नंबर ऑफ टीथ. ओके, सो इनवर्स ऑफ डायमीटरल पिच. तो सर अभी मॉड्यूल को आप बीच में मत लाइए, हम लोग वो लास्ट में कैलकुलेशन करेंगे सर उसका. अभी तो पहले एक तो लॉजिक ये है कि भाई ये जो सम ऑफ द टीथ्स है दैट हैव टू बी कांस्टेंट. सर टू मेक सेंटर डिस्टेंस सम ऑफ द डायमीटर मस्ट बी सेम फॉर द टीथ सम टू बी सेम, मॉड्यूल इज सेम. यस इट विल बी सर, इट विल बी सर, आप डरिए नहीं, इट विल बी. दैट इज व्हाट वी आर trying to do it. That is why I am saying that it's a iterative process. पहले गियर रेशो तो सर फिक्स करो, फिर बाद में यू कैन डिसाइड दैट. आगे बढ़े क्या? $33. So this TB is 33. Now you know that TD plus TC is equals to TA plus TB. So TD comes out to be TA plus TB minus of TC. So TA कितना है आपका 22 plus 33 minus TC कितना आया हुआ है, TC आपने 15 लिया, तो सर ये 40 आ गया. ठीक है, तो ये सर अब इसको मैं अभी 40 लिख दिया. Okay, now the gear ratio based on the calculation. So gear ratio for first gear, this I will say the actual gear ratio. So actual gear ratio, so this is G1 is TB by TA multiplied by TD by TC. So TB आपका दिया हुआ है 33 डिवाइडेड बाय 22, TD आपका 40 है डिवाइडेड बाय TC 15 है. सर इसका वैल्यू बताइए मुझे कितना है. तो ये तो हो गए ऊपर 3 नीचे 2, ये 20 हो गया, ये 5 हो गया. So this comes out to be 4. Yeah. So sir we started with the gear ratios. कितना उसने दिया था, 4 point something दिया था ना, 4.2 दिया था, but actually when we designed it comes out to be 4. 4.2 was given, then we landed up with 4. Please understand that if you change slightly, if you say that the TC you assume as 16, then TA you assume as 23, then TD you assume then you calculate, then TB will change, then TD will change. So gear ratio may slightly near up to 4.2. Okay. So that is what I am trying to tell you, that there is nothing like a right or wrong answer. You have to follow the iterative process. So first make these things, the center distance we will calculate in the end. तो सब गियर का मॉड्यूल लेके फिर सेंटर डिस्टेंस कैलकुलेट करना इजी हो जाएगा। पहले नंबर ऑफ टीथ फाइनल कीजिएगा, ठीक है। तो सर ये हो गया। नाउ फॉर सेकंड गियर, नाउ फॉर सेकंड गियर रेशो। तो सर सेकंड गियर रेशो उसने क्या दिया है, वहां से हमको स्टार्ट करना है। सो G2 सेकंड गियर रेशो, दिस इज गोइंग टू बी TB by TA multiplied by TF by TE. So this he has given as 2.56. अभी TB by TA अपने को मालूम है, so TF by TE, so TF by TE comes out to be 2.56 into TA ऊपर जाएगा by TB. So let us say this is 2.56 multiplied by ये TA कितना है अपने पास 22 by 33. So this comes out to be 1.71. So you know that TF by TE comes out to be 1.71 and also TF plus TE is equal to 55. तो ये E and ये F ये आ गया आपके पास 55. सो देयरफॉर अगर यहां से इवैल्यूएट किया आपने, सो 1.71 TF प्लस TE इज इक्वल्स टू 55. ये TE चाहिए. So from here TE comes out to be 20.3. So assume this as 20. So if you assume 20, so TF will become 55 minus 20, that is 35. So TE आपके पास ये आ गया 20 और TF ये आ गया 35. Okay, so now actual gear ratio, actual gear ratio G2, that becomes G2 becomes 33 by 22 multiplied by 35 by 20. This comes out to be almost 2.625. तो सर उसने दिया कितना था, 2.56 दिया था, ये 2.56 दिया था, तो ये हमने यहां लैंड हो गए. So 2.65. So what I will say, on the similar lines you go on doing for third gear and last gear you don't have to do, and reverse के लिए. तो सर ये करके देखिएगा, आपका समय हो रहा है करके, फिर मैं अभी एक्सटेंड नहीं कर सकता. ओके, so I will stop sharing. I will share the PDF with you and then please try to complete it. So over from my side, you may leave the meeting if you do not have any doubt.